Hello, this is Danny from CG Dreams. Today we're going to be dealing with UDIMs, and in particular within Cinema 4D and with Redshift. I'm going to be talking about what are UDIMs and how you would set up your UVs for UDIMs, and I'm going to be running you through the settings that I use within Zbrush to generate the texture files. We're going to be looking at the files that are generated, and in particular the actual name convention that it uses, and then finally we're going to be looking how to set the UDIMs up within Redshift. UDIMs are set up in the process of doing your UV mapping, and right now you're looking at a program called Unfold 3D. And this is my chosen choice for doing my UV mapping, so this is why I'm showing you in here. Also, it's the fact that at the moment Cinema 4D doesn't natively support UDIMs. In the right hand side of the screen, I want to draw your attention to this box here. This box unifies the area in which the UVs fall within. Now inside Cinema 4D you will see a similar thing. You'll see this grid box, and all your UVs for your 3D model must fit within this grid box. Now when it comes to working with UDIMs, you can have multiple grid boxes, or as they're called, tiles. Now when I turn on the UDIM function within Unfold 3D, you'll notice that we've now got many tiles, and you can actually expand this into hundreds of tiles if you wanted to. Each tile is available for a separate texture, which basically means that if you was to produce 4K textures for this model, it will create one for this UDIM tile, one for this UDIM tile, and one for every single UDIM tile that I spread my model across. This results in you having very high quality resolution textures. Now the downside to this is you're going to be producing many files, much more files as if you didn't use the UDIM feature. As an example, if you wanted to produce a diffuse color map and you had two UDIMs, you would have two textures just for that color map. Imagine that you spread this model across 5 UDIMs. You'll have 5 files just for your diffuse color, 5 files for your displacement, 5 files for your reflection. I'm going to show you the workflow within Zbrush of how to create textures using the UDIM for your model. But there are some similarities between this and other programs which I will highlight later on. For now, let's go through the process of what you need to do inside Zbrush in order to generate UDIM textures. If you don't use Zbrush, please fast forward to the next section. Inside Zbrush we use a plugin found up here, and the plugin's called the Multi-Map Exporter. This has the options to use the UDIMs. Now we need to dock this over to the left hand side, so I'm going to click on this radio button and it goes over to the left hand side, and then we click on this Multi-Map Exporter. Here you've got the option to choose what type of map that you're going to be creating. And with this particular case we're going to stick with the displacement for now. And then if you go and scroll down a little bit further, you're going to see some options in here, and by default it will be closed like this. So we need to expand it to see the options, and within here we see the options for the particular type of map types. We're going to be going for a displacement map, so we're going to expand this. I'm going to just reset this so you can see what it looks like by default. So let's quickly have a look through these options. The first thing is right at the very top will be your map size. So I'm going to choose to go with a 4K map per UDIM. The flip vertical will depend on whether your UVs are actually the right way around to start with. So to determine this, we can go to the right hand side where we've got the UV map menu and we click on Morph UV, and you can see that my UVs are the correct way around. So for me, I don't need to use the flip vertical. If they are the opposite way around, upside down, then you may want to use the flip vertical. But this will depend on what the UVs are in your target application, such as Cinema 4D. The next thing we need to look at is, going down a little bit further, is the name options in here. Inside the name options, you've got this UV tile ID format, and it needs to be set to UDIM. It could be one of these others just by clicking on here, but if we go to UDIM, that's the one that we want. Now inside here we've got these suffixes. Now what these are is it would include these suffix namings inside the file, and what this will do is it will help you determine what type of file that it is. As an example, Displacement Map is going to put the DM inside the actual file naming. Vertex with vector displacement, normal map, texture map. You can type something in there of your own, so that's to say diffuse, so we can say this is a diffuse color, ambient occlusion, but you can choose what you want in here. I'm going to click OK. I'm going to, I think it was TM to start with. I'll just put that back to where it was and click OK. Next down, moving from here, we got the subdivision level. Now my model is at sub-D level 1, and it so happens that inside Cinema 4D my model base mesh level is also sub-D level 1. So for this reason we need to make sure that we're generating the displacement maps from that level. If however you've taken this model over into Cinema 4D and you're going to be working from level 2 or level 3 as an example, you would make sure that you want to generate this from that level that is within your target application. So we would maybe slide this up to level 3. The reason why you need to do this and have this match is because you need to make sure that the displacement is going to displace it accurately according to the level that you're using in your target application. In my particular case, it's Cinema 4D. The next thing we need to go down to is this area here. We need to have smooth UV on, and you see here where it says mid 0.5. This is a setting basically set up for 16-bit displacement maps. So just to briefly explain, 16-bit uses a grey scale value of 50% grey, and this is what this 0.5 represents. If you're going to be doing 32-bit displacement maps, you want to have this set to 0 because it doesn't work on the same basis. The next thing is we go down a little bit further. We've got this scale and intensity, and this normally needs to get left exactly the way it is, but there are some exceptions. If you find that the texture maps are coming out too weak or too strong, the chances are that at some point you rescaled your model, either in the external application and brought it back into Zbrush, or you've rescaled it inside Zbrush. But normally it's not really posing a problem inside scaling with inside Zbrush. It's normally when you do it outside that it creates a little bit of confusion there. So in those particular cases when your model is not the ideal scale or unit size for Zbrush, you're going to use this option called Get Scale. And in this particular case, this model is 173 centimeters tall. And before I'd done the rescaling, this would have been 173 meters tall because the scale convention inside Zbrush is in meters. For this reason, this scale is much smaller than what Zbrush would have normally liked. So this is when we use the Get Scale button. So I'm going to press this now, and then when this is done, I'm going to come back and show you what's been changed. And it will be just the scale and the intensity. So it didn't take too long to do that as it happens. You can see that it's taken the scale up to 11.17 and it's changed the intensity to 0.0283. Now this intensity level, which is really handy to have this, gets put inside the actual naming of the actual file, and I'll show you this later on. Also, you want to just take a note of the scale, because we're going to need to know these two values when it comes to Redshift later. So moving on, the next feature that we need to have turned on is this 16-bit scale. If you don't have this turned on, what will happen is that each UDIM tile will get analysed and scaled independently, and you're likely going to have slightly different scales on each UDIM tile, which means that they're not going to work together very well. You're going to see seams basically coming out of your displacement, and that's not a good thing. So we need to have that turned on. When we've done that, the next thing is to click on Create All Maps. And if you're going to be creating your color map, your diffuse color map, you would also turn on this as well, Texture from Polypaint. And that will include maps for that as well. When you do that, you're going to be given a choice to give it an initial name of the file, and then all the rest of the file naming convention will be added by Zbrush. And some of these particular numbers it adds in there are very, very important. Now that we've generated the texture, now it's time to look at that particular texture to see how it's unique for UDIMs. Note that I created a folder called TEX, which is the default folder naming convention for Cinema 4D. And this makes sure that when the textures are located inside this folder, that they're kept local to Cinema 4D. The whole external link to another folder is not needed that way. So I'm going to go inside here, and you can see that I've got a number of files, and the one that we're looking for is the one which has DM written in it. In particular, these two here. Now, for the purposes of clarity, I'm going to put them in this folder just temporarily so we can just see these two. So you'll notice that the first part of this naming convention, this is what I would have typed in up to this point. Okay, and then from this point onwards, this is what Zbrush has typed in or added to that file. So the DM means it's a displacement map, and then we've got this bracket with a 0.0283. This is the intensity level that's been set by Zbrush. If we go into Zbrush, you can see that the intensity level of 0.0283 has been added to the file name. And then last but not least is the UDIM number. So 0.002 would indicate that it's the second one. We've actually got one here called 1.001. So whenever the file names are identical, apart from the UDIM, the target application or render engine is going to see this as a set, a UDIM set. If you didn't have the option turned on inside Zbrush with the 16-bit scale, what would happen is that each file wouldn't only not work very well, but it would have a slightly different number put in the intensity level inside here, which means it's actually changed the name convention so they no longer match. So if you find that you're applying everything and for some reason your UDIMs are not working inside Redshift, just check the name convention, because it may have a different intensity level put inside each of the generated textures, and they should all be identical. With that done, we can now move on to the next stage to actually apply these inside Redshift. So we've now gone over into Cinema 4D S22, and we're going to be setting up Redshift. The first thing that you're going to need to do is you're going to need to enable the Redshift engine, which is already done, as you can see there. The next thing you're going to want to do is put a couple of lights in there. So we go to the Redshift and add some lights. And then I want to select the main body. I'm going to right click and I'm going to select the Redshift tags and then choose this Redshift object. Immediately you want to go to the geometry, override, enable tessellation and enable displacement. By default you'll see this enable auto bump mapping turned on, and what this does is it will speed up your rendering by not applying as many subdivision levels to the mesh at render time, but will get all of the high frequency details if there's any inside your displacement and apply it as a bump. If you want it to be raw subdivided geometry, you can turn off this auto bump mapping and instead you'll have to adjust this minimum edge length. And the rule of thumb is the lower the edge length, the more tessellation or micro displacement that you're going to get. So we're going to leave this by default exactly as it is, and we're going to create a material for our object. So to create the material, we go to create, we go to Redshift, materials, and then material. And I'm going to name this body and drag and drop this onto our object. You'll notice that we've got the IPR. To select the IPR, we go to Redshift, and you can see this Redshift viewport IPR, so it's called the VIPR. I'm going to turn this off just for the moment. We're going to open up our node space, so we're going to double click on here and we're going to open our node space, and this is what it will look like. Now don't be too concerned about nodes if you've never used them before, because it's actually much easier than you actually may think once you start to use it. So the first thing I would normally do is we go to our base properties in there, and I would normally have the roughness to say 0.5, otherwise it's going to be too glossy. You don't want that to be the case. Now we need to bring in our displacement node, so we type in DIS and you'll see that it automatically shows you this. We're going to drag and drop it and then plug this from the output to the input of the surface, and then you can see here that we've got displacement there. The next thing is we need to bring in our displacement map, and just to show you, here's all of our maps, and the one that we want is the first UDIM of the UDIM set, which is indicated by this UDIM number 1001. So what I'm going to do is I'm going to drag and drop this into the node space, and then we can just simply go to the output and then plug this into the input of the displacement. It's as simple as that. If you didn't want to drag and drop from your browser, you can go and type in TEX for texture, and you can drag and drop this texture in, select the path to where the texture is, and then do the same thing, plug it in. There's a couple of things we need to set up with the texture. The first thing is we need to make sure that it's definitely having a gamma of 1. So I'm going to click on the gamma override. We don't have to do no more with that. The next thing is we need to tell Redshift that we're actually using a UDIM set. So in the path where the name is, you'll notice you've got this 1001. We need to select this and delete this out and replace it with the left hand bracket, which is the shift and left bracket, and then type in UDIM, all uppercase, and then the right bracket. And then you'll notice instantly that your little preview will come back. This means that now Redshift is looking for the next file automatically, which is 1002. And if there happens to be loads of UDIMs, 1003, 4, 5, 6, 7, Redshift will take care of it and it will automatically load it. Now that we've done that, we need to now click on the displacement node and set a couple of things up. Now you'll notice here that you've got this min and max value in here. This is the range, and it's set up for a 32-bit displacement, and we're using 16-bit. Now if when you created your displacement map inside Zbrush, you didn't change any settings over here, you didn't use this get scale function, the way you would set this up in here would be minus 0.5 for the minimum range, and the maximum range would be 0.5. This is telling Redshift that we're using a 50% grayscale map, which is what a 16-bit displacement map is. In our case, we did use this get scale, and what it's done is it's changed the intensity, And because of this, we're going to use this value in here of 0.028 inside here instead. You also find that it's there on your file as well. So there's 0.0283, 0.0283 is the number that we're going for. And it should be a minus value in there. Naught 0.0283 and 0.0283. Okay, this scale, we go into ZBrush, you can see the scale is 11.17. Normally it's 1, but this scale is being set up differently. So 11.17. That's as far as you need to go with that. And then you can go for a preview to see what it looks like. We now need to select our tag and make sure that the displacement scale matches what we've already got, which is 11.17. And now you see that the displacement has now come through. Go a little bit closer. So that's good, that's all come through really well for us. And that's really it, that's a setup for displacement. You'll notice that we've got no seams or any ugly hot spots on there. Now if we go back to our tag and we turn off the enable auto bump mapping, you'll notice that the high frequency detail is gone, but we can then change the edge length and bring this down and you'll start to see this detail come back in. But it will be at an expense of render time. So what you can do is you can go back to 4, turn on that. You can see it's coming through nicely. If you didn't want to go that route and you wanted to create a separate texture map just for detail and a separate texture map for more the lower frequency detail, then you can do the same thing. What we do in this particular case is we set up what's called a displacement blender, and I'll show you how to do that in the next video. So in this particular case you can see here that these two UDIM displacement maps, I've added the name in detail. You'll notice that when I open this up there's no low volume displacement in there, which is what I want. And yet this displacement has got all of the low volume displacement in there. Of course, in this particular case for this tutorial, I've included to have all the detail and the low volume in this displacement map. But I'm still going to show you how you would set this up inside Redshift. So with our node space as it is, very simple and set up, we will go to our node space and type in DIS for the beginning of spelling displacement, and we will include this displacement blender. This displacement blender allows you to blend up to 2 additional displacement maps on top of your main displacement map. So what we do is we will plug this into the displacement where the other one was, and then we will plug this displacement, which is the original one, into our base level input. Now I'm going to go and drag my UDIM for my detailed version of my displacement, and that's UDIM 1001. We need to obviously enable the UDIM, so we're going to delete this. Put in this string UDIM. We're going to need another displacement node, so we're going to copy this, control key and drag, plug this in, and then we will plug this into the displacement blender layer 1 input. Now what will happen is when we go to the Displacement Blender, we want to make sure that the additional detail displacement map is going to be added on top of the original. So this is called Additive Mode. And then we just ramp up the amount of detail we want to mix in there. So if I want the full amount, I can just ramp it up to 1. And then what this will do is it will give me that layer of detail. And you can add another one as well, like another layer. So you can have essentially a base level displacement, which is for larger volume displacement. You could have another displacement which would maybe include just your skin pores. And you can have another displacement generated in a Zbrush layer, which may include eyebrows or scars or something else that you wanted to just dial in there. That's as simple as it is to set up. Once you've set that up, then you're going to be able to see the details for all of that. The only thing that you'll need to make sure you do when you do this kind of method is to select your tag, turn off this auto bump mapping. You won't necessarily need that now. And then you would have to make sure that you will change your minimum edge length. By default, it's at 4. If you want your displacement detail to come through from the secondary map, you need to have this quite low, which is why I put this down to 1. When you've done that, then you're going to have all of the high frequency details coming through on your model, and they'll all come through and you'll see it all in their glory. The only thing left to do really is to set up some subsurface scattering, add your diffuse map. And you add the diffuse map in the same way. You would put your UDIM in there, change your UDIM string to be the left bracket UDIM, then the right bracket inside the name, and then you'll have that set up as well. Here is the setup with the maps applied, and the node space looks like this. And I'm just going to dissect this down a little bit for you so you can see what's going on. So this is a texture set, again it's UDIMs. This is for the subsurface scattering amount. So I'll just find this so you can see what it looks like. You can see here the ears have got more subsurface scattering amount on there, so that deals with that. This is a color correction, so what I can do is I can adjust the gamma just so that it can pull through more or less of the subsurface scattering amount. That's if your texture didn't fully do it in the first place. So we can just move that out of the way. The next one here is the diffuse color. So I plugged the diffuse color into the diffuse color of the material. And again, I just use this name convention UDIM, as you can see there. Nothing special there. I did make sure that it was definitely using sRGB for the color information, so I turned on the gamma override for that. So that's quite simple. And this one here is a roughness map. This will control how glossy certain areas, for like oily areas of the skin is. So that was just quickly made, nothing special there. Again, I used a color correct to adjust the gamma for that. And then we've got this absolute, which I don't need anymore, but I used this to initially set up what kind of scale between black and white that I wanted to drive some of these. Just gives me a good idea. This one here is a Subdermis subsurface scattering color that I plugged in, and again I used this color correction, and let's just put this down and out the way here so we can not have these wires over crossing each other. I'll plug this then into the multi-scattering color 0 and 1, and if we go to the multi-scattering, this is layer 1, this is there, and layer 2, and it's like that. It's a ready color map that I plugged into there for multi scattering. And then of course we've got our displacement setter as I've just shown you. We've got the main one, which is this one here. This is our main base level, and then we've got our detail level displacement. And that's the result from that by setting it up like that. Just add a floor in there and we'll go for a quick render. We can then choose to go to our Redshift and do a full sized render rather than in the viewport. We just hit this button there, and then off it will go. Once it starts up, it is pretty quick. Now the details that I put onto here were done really roughly and quick just to demonstrate this tutorial, so they weren't really using proper skin textures or anything like that. I just quickly used a brush inside Zbrush just to get a little bit of surface detail on there. Same thing with the diffuse color. That wasn't really applied as a final project. I've just done it for this tutorial just to project a bit of color onto there. So you can see around the neck here that it hasn't quite looking that great, but it's just for the purpose of this tutorial. But what you can see is you can see all of the skin detail come through on there, generated from this displacement map. I've done that in 1 minute 29 seconds.